Do you know where's the mic? That's all. Right. Okay, so we are left with a few more topics. Uh, Next is your last week, right? So you have classes till 6th, which is a Friday. You don't want to come next week? So there are few things we really need to cover. Otherwise, you'll have to study them on your own. I can give you the resources, but I don't think that's a relevant approach because you won't know exactly what to focus on. So the idea is today we'll talk about exception handling. Tomorrow I'll call an off. We won't have a class because we'll have a guest lecture um, during the lab time, and then we'll have one or two sessions next week. We'll try to wrap it up in month if possible. Okay, so today we are going to briefly talk about exception handling. How many of you have heard this term before in any other programming language? Can you raise your hands? How many of you have heard about exception handling or exceptions or let's say try catch? Have seen something like that? Two, three, four, five. Okay, a few of you. All right. So if you noticed in the code that you were implementing in the lab yesterday for implementing your GUI, ChatGPT itself, which was automatically including a try catch block, right? So we should know what that is and why we are using that. So we'll start with a small code. Okay, so look at this program. Do you think there is any problem with this? Any syntax issue, logical issue, or any other, or will it run perfectly fine? You can assume that the use of scanner is correct. You needn't check for that, whether we are calling the functions of scanner correctly or not. No classes, no nothing. Very simple programs. Any issues with it? Value of B, right? So there might be a problem with value of B, there might not be. So what the problem is doing, just dividing two numbers and giving you the result. So if you run this, let's say, right, so says enter two integers. So say 89 and 78, right, gives you a result as one an integer value. And if you run this again, so it really depends on what you put here. So if you put 78 and 0 here, the program just crashes, giving you out an exception saying that there is an exception in thread main. We haven't yet discussed what threads are. So we'll do that next week. So here you needn't worry about this. So it says that I've got a java.lang.arithmetic exception. So there are two things now we need to address. First, the use of the word exception. It doesn't say it's a, although it looks like a runtime error, but the term used here is not error, it is exception. And second, if you look at this java.lang.arithmetic exception, what it might be. So we know that java.lang is a package, right? We have used many classes from there. In fact, all the wrapper classes were from there. Um, Object class comes from java.lang, etc. So what exactly is this arithmetic exception? It's also a class in Java, which is made to deal with exceptions. So So this is a bit of view of how classes related to exceptions and errors are arranged in Java. There is one more. So rather what we can do is instead of starting with this, you can look for and ask it for, let's say, arithmetic exceptions documentation. Let's go there and see what it shows us. Right, so you can see here that arithmetic exception is a class. So you can make out a few things from here. It's not an interface, it's not an abstract class, so you can make its objects. It's not final. If it was final, you couldn't extend it. So the point is, if you understand this class, you can even extend it. If you look at its inheritance hierarchy, so you have object, which is the superclass of every class. Then you have something called throwable. We'll talk about this more. Throwable has an exception, which has a runtime exception, which has an arithmetic exception. So the Java's inbuilt packages, they use this concept of inheritance a lot. And then you can just scroll down and see more things about this class. So there are certain constructors, there are certain methods, etc., which we'll look at in a while. But all in all, the point is this arithmetic exception is a class. And there are a lot of classes like that, as you see here. So you have something called arithmetic exception, that's a class. You have a null pointer exception, that's a class. Uh, all this comes in runtime exceptions. There are few other kind of exceptions, like if you are working with a database SQL exception, there are certain errors. So one point which is important here is, so you see, this is the inheritance hierarchy. Throwable is at the top, and then exception and error, they inherit throwable. Right, I have taken this diagram from an online source, but you see different online sources, they will show you the arrows for inheritance in really different ways. Right, so here you see a very different kind of arrow. Someone might not even show an arrow, there might be just lines, but the thing is, for us, we will stick to the notations that we studied in UML diagram. So you know how an inheritance arrow should look like. It's not like this, right? So there should be an arrow from exception to throwable, right? And an open arrow. So use those kind of notations in your exam. So we'll be sticking to them. Okay, now the question is, what is the difference between an exception and an error? So what both of them does is, all the issues that we have is during runtime. When you run the program, your program crashes. It might give you some kind of error, might give you some kind of exception. For us till now, both of them are same because the program crashes, but there should be some difference between them. As you can see, there are two different classes. Any idea? So there's a very thin line between exception and errors. So errors, if you talk about, they are something which are, you can say, devastating. So let's say you are going on a journey and the bridge collapses. So you can really not do anything about it. It's completely out of your control. So those kind of issues mostly count in error. Let's say you're running your some program and something in your hardware goes wrong, right? And it just stops, or your system just dies. And so that's a kind of error. Some other errors that you might encounter are out of memory error. Has anyone encountered that ever? That you were running a program and you ran out of memory? And you can smartly create those cases. Okay, one of us here. You can smartly create those cases. So what you can do is maybe create a dynamic array inside a while loop, right? And do not free up that memory. So every time the code runs, it keeps on using more and more memory, and eventually your system runs out of memory. A very interesting example of this is a fork bomb. Have you heard about that? Do you know what fork is? What's that? Okay, so give me the technical term. What is it? What it does is like that. Technically, what is fork? If somebody asks you what is fork, there's a name for it. Right. Next C program is written and you write a fork in it. What it will do is create a copy of the program. Programs will be running parallelly on your system. So fork is a system call. System call, right? You can just put it in a C program. You have a fork, and then parent creates a child process, and both of them start running. What if you put a fork in a while loop? a potential operating system exam question. So while one fork, what happens? So you are forking again and again. So what happens? So you have this, let's say one process running, it calls force. What happens? Creates a copy, a type program, and both of them are running. Then we get the fork again. So both of them fork. In the next step, you again have a force. All of them create one more child process. So what it is essentially doing is you have more processes being created in your system, and that their numbers are raising exponentially, not even linearly. It's like human population. 1 to 2 to 4 to 8, right? And your system memory will just crash. So right now, if you look in your systems, there are ways to get rid of the fork bomb, but previously people used to use it like, you see, you might have heard of denial of service. It's so if you were submitting an assignment, let's say to your instructor, put a fork there in a while loop and their system would crash. Anyhow, that would not happen now. So that's an error. Another common type of error you would have seen is stack overflow. This is very common. If you are writing a recursive program and you do not give it a base condition. So the point is it never returns. It just keeps on going, calling and calling, and your stack overflows. The call stack. Another kind of error might be linkage error. Some file is not getting linked correctly. So we usually don't mess with these kind of situations. We'll talk in a while why. Exceptions are something which are creepy but not as devastating as errors. So let's say you are again going on a journey and you have a naughty kid who punctures your car. Now, the point is, if you were smart enough, you would be having some kind of backup plan. You would be knowing that this kid is like that and something might go wrong. So you might have some additional tools with you to take care of that. So that way you should be a smart programmer to know that, okay, well, something can go wrong with this program at runtime and I need to address that. So those kinds of problems count into exception. So as an example, array index out of bounds. If you know that if your array is of size 10, you know that nobody should be accessing A10. And because your indices run from 0 to 9. We have also seen some of these exceptions time to time. Number format exception, if you're giving a number in incorrect format. File not found exception. You're opening a file which doesn't exist. Class cast exception, we have seen that in few of the lectures when we were talking about runtime polymorphism. So all in all, the point is exceptions are something that you should try to deal with. Errors are something you should let go. So very much like situations in your life. When some challenges come, exceptions are like those. You should take responsibility and get over them, resolve them. Errors are more like those situations when we say, okay, let go. Right? Some situations you should let go. So why do we really let go of these situations? Let's say a fork bomb or infinite recursive call. So what we mean here is if you see here particular program, you know that if B is 0, this program is going to run into an exception. And it's a small exception. You know that if we are careful enough and we ask the user that you shouldn't enter 0, we take care of it. It's a small issue. So what we are doing here is one thing in exception handling, you handle it once the problem has occurred. It's very different from using conditionals that we'll talk about. So you can always say, why are we even learning this? You put a if loop and you say that if b equals to 0, then you print a message that I cannot divide, otherwise you go on. Right? But exceptions, they are something different. We are saying let the problem happen, and once it will happen, we'll take some measures to correct it. You do not do that with errors, because the idea is once a fork bomb has started being created at the level of your operating system, as a user you can't really do anything about it. Even if you resolve some things in your respective program, your system is in a very inconsistent state and your memory is being eaten up. So whatever we'll discuss in this particular topic will be related to exceptions and not errors. Coming to the next question, why not use an if-else loop here? If-else conditional here. And why to let this problem happen and then resolve it? So there are majorly two reasons for this. First is how many exceptions will you take care of? Can you guess how many exceptions are there in Java roughly? All the things that can go wrong at runtime in your program. More than 100, right? So the point is, as a programmer, you'll have to be very careful to see that, okay, one of those 120 or 150 problems is occurring here, and I should in advance put an if-else loop there. That itself is costly. And even if you do that, it's very likely that something or the other will just, you will leave it. It will go out of your attention. Second, it will make your code very clumsy. It's an if-else. Third, and the biggest reason can be, you see, as the name implies, exceptions, they happen once in a while. So mostly, why would someone divide by zero, right? People are not that malicious that every time, whenever they run the program, they'll try to create an exception. Maybe an exception will occur 1 out of 100 times. And if you put an if-else loop there, you are checking the condition all of those 100 times. We don't want to do that. That's an additional overhead. So now the idea is, how do you deal with this exception? So you already have some idea about that, right? You use a try-catch block. So what you do is, you see that this is a line, let's say line number 10. This is the line which can create a problem in your code. So you put this thing in a try block. Only this one line, right? This one line means you try it and see whether everything goes well or not. If everything goes well, fine. Otherwise, what will happen? There will be an exception which will be created by this division operation over here, and exceptions are thrown by that function. That's why if you look at the name of the base class, that is throwable. That is a class or an object that can be thrown. So your code throws an exception. When it throws it, you need to catch it and deal with it. So how do you catch it? So there's a catch block. And here we'll define how do we catch it. What you write inside this catch block is what type of exception it is. Right? So in our case, it was arithmetic exception. Since it's in java.lang package, I can just use this class name directly from here. So I'm copying it and put it here. And what I'm catching is an object of arithmetic exception class. This E can be anything. It's the name of an object. You can even write something like obj here. And that's all. And you can put here howsoever you want to deal with it. So maybe right now, I just want to print a simple message. And maybe I'll say infinity. Right. So what will happen now? Your code will not crash. The moment an exception is thrown here, it is catch. It's caught and it shows you this. And it shows you infinity over here. Okay, now there are a few more things that you can do here. So if you look at the arithmetic exception class here, so let's again go back to the class and have a look at it. So few more things we should understand. So if you look at arithmetic exception, you see it has certain constructors. Constructors means you can create an object of this class. But you should note that in this particular case here, we are not creating any object. Where is the object being created? The function which is responsible for dividing. So once you are trying to divide something by zero, that function in itself creates an object of that exception and throws it. So you are not creating any object here. You are catching that object of arithmetic exception, and then you can use this object in various ways. So look at these methods that you have. So a few meaningful methods here can be, so look at this, you have something called get message. You have get stack trace, print stack trace, toString. You can try some of these methods. So let's look at get message. So since it's a method of this arithmetic exception class, so you can call this method with its object. So let's try to see what happens. So what I'm going to do is, instead of printing anything here, I'll say obj dot, and let's invoke that method here, which is get message, and see what change happens. Right. So this message says divide by 0 and you needn't write it. So the point is this exception object itself knows why was this exception in the first place and it prints a message for you. If you want, you can also use the toString method. If you remember about the toString method, that's the one that comes from the object class. What does toString do by default? Do you remember? We create any class and you call the toString method. What does it do by default? Give a hash code, right? Or whatever the object is. So let's see what happens in this case. Does it give a hash code? Right? It doesn't give you a hash code. Shows you what kind of exception it is and shows you the message. So the point is this method, it is overridden in your arithmetic exception class. Right. Okay. Can there be any other kind of exception this program might cause? So we have dealt with one kind of exception, that is when B is 0. Any other thing that can go wrong here? What are all the malicious things you can try to do at the runtime? What if you do not give it an integer but something else? Right? That's yet another problem that can occur here. So let's say that's what we discussed before you came. Okay. I'll fill you in later. So enter two integers. So I'll put my name in here and that's definitely not an integer. And what scanner class is looking for is an integer. You do this, you get another kind of exception here. And this is input mismatch exception. This also tells you one more important point. If you look at this particular exception, it's not in java.lang. It's in java.util package. So all the exceptions, they might be scattered along multiple packages. And since this one is in java.util, you need to import this one. If something is in java.lang, you need not import this. So let's try to catch this input mismatch exception. So what will you do? Things can go wrong here also if you do not enter correct input. So I'll put it this in our try block. Have one more catch block here. And it's yet another input mismatch exception. Give its object any name, let's say E. And you can print your, so instead of just printing messages, you can deal with it in whatever way you want. Maybe you want that if user enters some string, you will give them values like 1 and 0. So you can even write something like A equals to 0, B equals to 1. It's totally dependent on you how you want to handle this exception. But for now, we are just printing these messages, showing what went wrong without making the application crash. Right, so show me what is e.toString. So I'm catching another exception here. And now when you run this, you see a lot of errors and it says, I do not know what is input mismatch exception. That's just because what we discussed, it's in java.util. So what I can do is maybe put a star here, right? So every class from util package counts. Now we get another problem. It says cannot find symbol. Okay, can you tell me now what went wrong here? So it says still here what everything is fine, but in 18th line I cannot find the symbol A. Why it can't find the symbol A? It's a compile time error, not an exception. Because you have defined A inside the try block. Right? It's localized. So outside this, so the scope of A and B becomes this. Outside this scope, your program knows nothing about A and B. You would have seen this in C also. Right? You put something inside two curly braces or inside a function, it's a local variable. So what we can do is maybe just declare your A and B here. and give them values here. Okay, so now we won't see that. Okay, now we get another problem. It says that A and B might not have been initialized. Right, so you see it's smart enough to see that. It sees that, okay, in some case, maybe you do not execute the try block at all. You are only executing the catch block. In that case, A and B, they are not initialized. They do not have any initial value. So either you can give them some initial values here, or you give them some initial values inside the catch block. Or do is, in case you are coming to the catch block, that means A and B have irrelevant values. So I'll just make my program return from here. Sorry. Return means I didn't get the correct values for A and B. They are not integers, so do not proceed further. Okay, and now when we run this, give me two integers, say 89 and 78, then everything goes well. And if you give it 89 and 0, then you see the arithmetic exception. And if you give it some alphabets, then you see input mismatch exception. Okay, so this is our code. Now we can do a few things to make this code more crisp and concise. So first of all, you see we have one try, one catch. Then we have another try, another catch. Right, so can we reduce the number of try blocks and catch blocks is the next thing we can work at. So maybe I can put my whole code inside one try block. Right, instead of having two tries, what I'll do is I'll remove this try and I have this statement. I'll just remove this and place it here, right? No problem. So what we are saying is, okay, there are these three lines. You try to execute them, and anytime if you have any problem, we have two catch blocks. One for catching the exception with these two lines, another for catching the exception with your 12th line. And you can run this. This code will work in exactly the same way as before. So if you say 8 and 0, it gives you an arithmetic exception, and if you give some alphabet, it gives you input mismatch exception. Okay. Now next thing, can we merge these catch blocks together? It's okay about the try block. Can we also have just one catch block rather than two? So well, we can have. So what you can do, just like in if conditions, you can use something called or. If this happens, or this happens, or this happens, you do this. You can do the same thing here. Right? Or here is with this single line. And yeah. So it can either be an input mismatch exception or it can be an arithmetic exception. And whenever it happens, you do this and I'll just get rid of this. So we have just one catch block which is taking care of multiple exceptions. And still your program will run the same way. You can check it. I'm not executing this again. Okay, anything better that we can do here? Can we make this catch block all the more simple? And the hint is with the idea of runtime polymorphism. So what we are saying, okay, if input mismatch exception comes or arithmetic exception comes, you do this. Now, what is interesting is if you look at input mismatch exception and arithmetic exception, both of them are derived from runtime exception, right? So what you can do? You just put runtime exception here. You do not need two types of exceptions. So if any kind of runtime exception comes, no matter whatever type it is, it's going to work. And if you want to go one step further, since exception here is a super class of all the exceptions, you can even write exception E here. So if any kind of exception comes in your code, it will come here and show the message accordingly. Okay, any questions so far? Okay, there's one more thing that you sometimes do, which is rarely done. So, as an example, if you see in this code, we are using a scanner object, right? With a scanner object, you create this object, and at the end, it is mandatory that you close this object. Right now, what will happen in this code is if there is a problem in the try block, it will run the catch block and your program will return. The scanner never gets to close. Getting my point? So if you do something wrong here, it says, okay, there's a problem. It goes to the catch block and there's a line in this catch block which says return. So return means it will return from your main function and the program will end. So the scanner doesn't close here. So although for your small applications, it doesn't make a lot of difference. But if you are doing work on a big project dealing with files or database connections, you should always close them. So how do you ensure that this line always gets executed? Even if there is a return in the try or the catch block is, you have one more block which is called finally. So you can put this line in finally block. It's rarely used. I'm just telling you for information. So what it will do, you can even put a SOP here to see what is happening at your end. But the point is, after catching the exception, it will come to the finally and it will close your scanner. So after everything, this will be done. Okay. So yeah, a few more things. Now we can say, okay, I don't want to learn exception handling. Anyhow, if the exceptions happen in my code, let it be. I don't want to learn a new topic. So let's see why it becomes very important in certain cases that you know exception handling in Java. So this is yet another code. We haven't discussed file handling much. So the point is there are classes which you can use to create files and work with them. So do not worry about this code. All this code is doing is it will create a new file for you, example.txt. It will write this string to your file. It will close the file. It will again open the file, read this file character by character, and that's all this program is doing. If you look at it, there is syntactically nothing wrong with this program. Right, that I am guaranteeing you. There is nothing syntactically wrong. But let's run this program. You see, we get tons of errors. What do you think these errors are? It might feel like, okay, maybe this error is a runtime exception. Again, there is nothing wrong with the syntax. So what it says is there are unreported exceptions, some IO exceptions, which should be caught or declared to be thrown. So it's difficult to make out what these errors are saying. But what is happening in these cases is in certain particular cases, your compiler sort of foresees it. It doesn't do it for runtime errors, but let's say if you're working with a database connection, or as in this case, you're working with a file, it knows that maybe tomorrow your friend runs this file and he or she might not have a file example.txt or something might go wrong. So in the case of files, when you are opening a file, it might not exist on your system. So what the compiler is doing, it is forcing you to put an exception handler here. And until and unless you don't put that, your code is not going to work. So there are certain cases in which it becomes mandatory for you to put a try catch block. Otherwise, the code will not work. So there are two ways we can. So there is nothing wrong with this code here. It is perfectly fine. But it's a compiler enforced check here that while file handling, things can go wrong. And you should definitely put a try catch thing here. Definitely handle that exception. There is a name for these kind of exceptions. They are called checked exceptions. Checked as in checked exceptions. Checked because your compiler is checking for them. So mostly if you look at this figure, this one over here. So all your runtime exceptions, they are unchecked. Unchecked means you needn't need to handle them. Even if you divide by 0, your compiler have no problem. Your code will crash. That is fine. So those are all unchecked. These are certain exceptions, IO exceptions, SQL exceptions, which enforce that you put them in a try catch block, else your code will not work. So there are a few things you can do here to resolve that. So one thing is obviously, as we were doing before, put it in a try block. So I'm going by the simplest and the shortest method. Okay, here is my whole code and something can go wrong with this. So you put this thing in a try block and just put a catch block, that's all. At the end, if anything goes wrong, you catch it and you can use the exception superclass here. Exception E. Let's say E dot toString again. Right there, it's all. And now you compile it, everything is good. And when you run this, everything is good. So there was absolutely no problem with the code. Still, it was giving you a compile time error because it's a checked exception and you need to handle that. There is one more thing you can do here. If you do not want to write all these try catch things, just get rid of them. And there is a keyword called throws here. So what you can do is you can just mention to the compiler, it's okay if this particular function main here, in my case, throws some kind of exception. You can even write IO exception or a subclass here. I'm just using exception. Right. So throws it. So there are two keywords again in exception handling, very much like you had two things, collection and collections, right? And they are totally two different things, very different things. Similarly, we look at two different things here, throws and throw. So this one is throws. Throws means, okay, well, here I have some code and it might throw some kind of exception and that should be fine with you. I don't want to handle it. So who is going to handle it? So when for any function you write throws exception, it is presumed that the function who is calling it, the caller of this function is going to handle it. In this case, it's a main function. So who calls main? JVM. In this case, JVM handles it. In case you had another function, so let's say in main you had something called F1 and all this was written in F1. Right? So in that case, F1 would pass the bug to the main function. So the idea is I'm not handling it here. It's up to the caller function to do this. And yeah, your code will again work pretty much the same. Right? So I think it's a better idea than using try catch here. But use it in case only when you are absolutely sure that your code will not create any troubles. Right? In that case, you can choose to throw the exception. Okay, one last thing. So let's look at this code here. Sometimes you might want to create exceptions of your own. So right now, if you look at this code, a bank ATM code, so no classes again here, only we have me. So you have some account balance, some withdrawal amount. And if you say in case your withdrawal amount exceeds the balance, you show them an error message, right? So maybe you do not want again to deal with it with an if else like of if else condition and showing an error. Maybe you want to create and throw an exception of your own. Can you do that? So right now, what we were doing, all the exceptions that were being thrown was decided from the Java side. If you are dividing it by 0, it will show you an exception. If you are using an array index out of bounds, it show you an exception. Now what we want to do, something is not an exception as defined by Java, but I want to say, okay, that is an exception for my code. Let's say you are writing a very secure bank transaction application, and there in certain cases if user tries to do something spooky, let's say like in this case tries to withdraw something that's not there in the account, you want the application to crash and throw an exception instead of just showing an error message with a if else. Right, so how do you do that? Right, so what we will do is, in this case, I don't simply want to do an error message. I want this application to crash with an exception. So in that case, you can induce an exception from your own side, and what you can throw is an exception object. That's how it is done at the side of Java. So if I can put it. So let's say there's a function called parseInt in Java. Some of you were using it. Like parseInt takes a string and converts it into an integer. So if you look at that parseInt function's definition, it will have something like this. In case what you have given is not an integer, it's going to throw an exception. So we are now doing that from our own side. We are saying, okay, if this thing over here happens, I am going to throw an exception from my own side. And how do I throw an exception? So to throw an exception, you need to create an object of any of the exception classes and throw it. How do you create an object? We know that's done with the new keyword. But okay, which exception class would you use in this case? Which do you think is the most relevant one? I'll create an object of any of these and throw it. But the point is, which one should we use? Our error is the problem we are facing is that what you are trying to withdraw is more than what you have in the account. I don't know what type. So maybe arithmetic exception since I don't know what it is. So see what comes closest to it. Maybe arithmetic exception because if you do that particular operation, your account will go to negative. So let me throw an arithmetic exception. So how do you create an object of arithmetic exception? And create it with the constructor, and you have two constructors over here, you see. So one is arithmetic exception default constructor, another is a constructor which takes a string. So let's go with the default one. So what I'm going to do is you throw this. You can also write it in two lines. You create an object and then throw it. But the point is new arithmetic exception over here will create an object of type arithmetic exception and it's going to throw it. So let's do it one by one. So if we were not throwing it, if we only had the if else loop, so let's see what would happen in that case. Right, so it shows you an error. So if your application doesn't crash, it just shows you an error and says that withdrawal amount exceeds the account balance. What we have done now is we are saying I don't simply want to show an error, rather I want to throw an exception, right? A runtime error. So let's do. You see, so when you run this now, you get an exception in the main thread and it shows you that it's an arithmetic exception over here. Okay. What you can do is you can also pass a message alongside it. So this is where we are invoking the default constructor to create an object. You can also call it parameterized constructor by passing some string over here. So maybe you can say, let's say insufficient balance. Right. So now when you run this, it doesn't show the message. Went wrong. Yeah. Right. So it shows you that there is an error and it also shows you your message, which is insufficient balance. Okay. Now the last part of it, you see now this arithmetic expression doesn't really suit it, right? So we have used it because there was an existing class like arithmetic exception, but you might want to create your own exception. Let's say something called a bank exception. So let's say you want to create your own exception by your name, which causes your application to crash if something malicious happens. So how can we do that? So what I'm looking for, you create your own exception class. And how do you do that? I don't want to rely on the existing exceptions, want to create some exceptions which are custom made for my application. And so you can create your own classes. And how do you do that? So if you remember when we discussed, we said that if you look at the exception class, it is not a final class. That means you can extend it. And you can actually extend any of the exception classes. So what you can do is, I'll create my own class, let's say called bank exception, right? And it can extend. So it can extend the base class exception. It can also extend any of these classes. That again depends on what type of functionalities you are looking for. If it's a new type of input output exception that you are custom making, then you should extend IO exception. Right. So you can even extend exception. So I'm going to extend, let's say, arithmetic exception. Extends this. Okay, and what happens when I do that? What happens when you extend a class? All the data members and member functions that were there in this class are also mine. So I can just directly use them. So as of now, I'm not putting anything in my own bank exception class. And instead of passing an arithmetic exception, since we created a new class bank exception here, I'm, let's say, going to throw new bank exception. Okay, now can you tell me what is the problem with this code? Can you figure it out? What's the problem happening? So it's related to inheritance, not related to exception handling. The problem that's happening here. I'll show you. Yeah. So the error says that the constructor that you are using in the bank exception class, it cannot be applied. There's something wrong with the constructor. Our bank exception class, it doesn't have any constructor of its own, right? So what all it has is only a default constructor. Okay. But what you are calling here is a parameterized constructor. So how do you resolve that? So one idea is obviously you remove this, right? So that's going to call a default constructor. Bank exception class, default constructor will be called. And if you remember, what is the one statement in default constructor? Calling the constructor of the super class, which is super. So if you look at this code right now, it is very much like as if you have written something like this. You needn't write it, but it will just be there implicitly. So what is happening is right now your program is like this. Right? So your bank class, it's calling the constructor of your arithmetic exception, but the default constructor. You can choose to write it or not to write it. Right now, if you run it, it looks fine. But yeah, I also want to see my message. I don't want a default constructor. I want a parameterized one. So what do? I want to pass in some string over here and that should appear in the message. You you make a parameterized constructor, right? And how you can do that? Very much like how you have done this here. You create one more constructor here. And in case you are calling the parameterized constructor of the bank class, you call the parameterized constructor of the super class. Right? So now you see your message over here. So yeah, that's all. That's mostly there to exception handling. So these are the major tools that you will use. So to list them over here, these are only the few things that we discussed here. And this is mostly what's there about exceptions. So first of all, why exceptions and no conditionals? That's what we discussed. Difference between errors and exceptions. You can merge multiple exceptions into a single one, merging your catch blocks. Checked versus unchecked exception. So all your runtime exceptions, they are unchecked. Your file, IO, SQL, database related exceptions, they are checked. That means either you need to apply exception handling there with your try catch block, or you need to throw it with the help of throws keyword. And then you can even throw your own exceptions and create your custom exception classes. Right? So I'll give you a few practice questions on this, which you can do. So yeah, that's mostly it. Next week, we have mostly one concept left, which is multi-threading. And the idea is again just to look at the Java classes that allows you to do that. Otherwise, I think you already know about multi-threading and semaphores and all those things. But the point is you have classes with which you can implement. So maybe I'll give you a demo of that. That's it.